Okay, another problem in 2D equilibrium. This problem, we have a log connected with like one cable up here, and then the log itself is rolling between a set of roller at B, and set of roller at C. Again, I know this structure is in equilibrium because it doesn't have any degree of freedom, right? Because if you look at the whole log wouldn't rotate, wouldn't move. It's gonna move down until like the cable here is gonna hold it. It's not gonna move up there. It's not gonna rotate because you have two rollers here, right? They're not gonna allow the rotation. What I have here for the tension on the cable, I have T. The log itself has a weight of 420 pounds that we place it in the middle of it, and then two reactions. One reaction at B, one reaction at C. Again, I put them this way. You can put them the opposite way. But what we know the reaction at B and C are perpendicular to the log because it's a smooth surface. There are two rollers, and those rollers allow to have like a perpendicular reaction. Now, to set up the equations here and to solve it, I'm going to go with the basics of those three basic equations. Those equations are sum of f of x equal to 0, and then sum of f of y equal to 0, and sum of moment about any point is 0. I'm going to select the point basically based on where we have the most number of unknowns or other judgments. In this case, if I started with the sum of f of x, on the x, so if you look at NB and NC, each of them, they have angle of 30 degrees with the x-axis. So I can break this one down. If I break down NC, I'm going to get on the x, I'm going to get NC cosine 30. Same thing here, I'm going to get NB cosine 30. Down on the y, I'm going to get NC sine 30, and then here NB sine 30. So I break them down to x and y components. These two forces, they were not in x and y. So sum of f of x equal to 0. What I have on the x? On the x I have, I'm going to rewrite the equation here. Sum of f of x equal to 0. On the x I got minus NB cosine 30 minus NC cosine 30 equal to 0. From this equation, you're going to get NB is equal to minus NC. Remember, this cosine 30 cross off of both of them, and then you can, this is what I'm going to get from this equation. Second equation I have the sum of f of y equal to 0. So I'm going to do it here. Sum of f of y equal to 0. On the y, I have minus 420 going down, plus t, which is going up, and then I have these two components. So minus NC sine 30 minus NB sine 30 equal to 0. Again, on the y I have four components, 420, the tension T, the NB sine 30 and NC sine 30, all pointing down. I need to find a point to do the moment about. So if I do a point moment about a point, I would have my third equations. Remember, we have three unknowns. We need three equations to solve it. So I'm going to find sum of moment about the point. In this case, I'm going to do it about point A. It doesn't matter other points, but I'm going to pick point A. On the point A, I would consider 1, 2, 3 forces. I can also break them down to components, but this time it's smarter not to do that. Let me say why. So for the W 420, the perpendicular distance would be the distance from the middle here, which is going to be this distance. And this distance is simply 7.5 sine 30. Remember, that's the distance which is opposite. So 7.5 sine 30. So and this is going to go clockwise about point A. So I have 420 times the clockwise distance is 7.5 sine 30, and this is the minus here. For NB and NC, I told you the wiser way is that don't even break them, because we say moment is force times perpendicular distance, and we already have perpendicular distance. Look at NB, the perpendicular distance from here to here is 10, right? I don't need to look at the components. If I look at the components, I need to do more work. That will be the perpendicular distance for NB, and the perpendicular for NC is this distance, which is going to be 15. So I'm going to have, this is going to be for the first 420. For the other two force here, it's going to be minus NB times 10 minus NC times 15 equal to 0. So if I bring here and substitute here, I can solve for NB and NC. So if I solve for NB and NC, I'm going to get like one of them positive, the other one I'm going to get negative. So actually I solved this problem with MATLAB 2 to get the answer for it, but I got like 315 for NB. So NB is 315 and NC is minus 315. If you take NB and NC and put it here, you can solve for T. And then I'm going to get for T will be equal to, T is equal to 420 pound. Again, setting up the same approach, the question I have from you, when I did the moment about point A, why I didn't consider T? Right? I consider every other force. I consider NB, NC, and I consider W. Why I did not consider T?
Is it not a force?
It is a force. It's tension. Because it is at that point, right? When you apply a force on that point, there is no moment about it. Okay, if the force crossing through the point, there is no moment. That's what we discussed when we were talking about moments, right? Moment is created because of perpendicular distance. If I talk about point A here, what's the distance between here and here? It's 0. There is no perpendicular distance, so that's why there is no moment. Similarly, in the other problem that I solved, I did not consider, when I was doing moment about point A, I did not consider AX and AY. And that's the whole reason I picked this point, because I have the most number of unknowns there. I would cancel out AX and AY in my equations, and I would be living only with T. So one more simpler problems. So in this simpler problem, I have two forces. Again, let's discuss what is this problem. We have a bar. This bar is connected with two cables, one cable at A, one cable at B. There is an external moment applying to the end of it, like you are twisting the end of it, right? So what we are looking for, to find the tension in A and B. So we can draw the free body diagram first. The weight of the beam is 120 kilogram. That will be applied to the middle of the beam. Again, the beam is homogeneous, which is going to be uniform. So at the middle of it, I have 120 kilogram into 9.81, which is the answer is this, 1177.2 Newton. And then again, there's no much more on the free body diagram. I'm going to set up the equation: sum of f of x equal to 0, sum of f of y equal to 0, and sum of moment equal to 0. So on the x, sum of the f on the x, there is no force on the x. So no use of this equation. The second equation, sum of f of y equal to 0. On the y, I have TA, tension of A plus tension of B. Again, those two are going up, minus the force down here, minus 1177.2 equal to 0. That's sum of f of y equal to 0. And sum of moment. I need to pick a point, right? I need to pick a point to do the moment about it. I can pick any point. by the way. I'm going to pick point A just to cancel TA, and then from this equation I would be able to calculate TB. So sum of moment about A is equal to 0. So if you could help me with the equations, I highly appreciate that. We have, again, TA, we wouldn't consider it in this example because it's moment about point A. There's no distance from A to A. Distance is 0. So what's the distance for 1177.2? 3 meter. And that's clockwise or counterclockwise? Exactly. So you put minus in there, right? So moving on to the second force. The second force is TB. How much the distance for TB is? 4. Yeah, 4 on the top. You see? Distance is 4. So, and that's going to go counterclockwise. So that will be plus. And then you have an external moment. This external moment, they don't have any distance because the distance is already in there, right? Newton meter. That's the unit for this. So is this clockwise or counterclockwise?
Clockwise.
Yeah, that's the clockwise moment. So you put minus 500 there. Now, from here, from this equation, I would be able to calculate TB. Once you found the TB from here, you put the TB in this equation, and then you can solve for TA. So I'm going to go through my notes. I found TA. Okay, I found TB is 1007.9, and then the TA, if you, again, you can rearrange here to solve for TA. TA is equal to 169.3. Okay, what's up? Do I have error in my calculation?
No, there's no error. I'm just curious, why did we go to solve TA first?
It doesn't matter. So, yeah. So this is the concept of problem solving in statics. You can go with any approach you want. You can do moment about any point, because if the structure is in equilibrium, it doesn't matter I pick point A or I pick point B, right? I'm going to get the same answer. If I do moment about point B, I would consider TA and I would consider W and this 500, right? So like for instance, if you want to rewrite that equation, sum of moment about point B equal to 0. So you would consider TA, and that time this will be clockwise, right? TA times 4 minus, and then the W is going to go counterclockwise, plus W, which is 1177.2. For this, you have to get the distance 1, right? Because distance from here to point B is 1. That's the perpendicular distance. 1 minus 500 equal to 0. If you solve this equation, you get the same value as 169.3 for TA. Okay.